Hello, how's it going? Welcome back to Object-Oriented Programming. Today we're going to start our next topic, which is pretty much going to see us through the end of the semester. We're just going to cover a couple little things here and there as we go, but most of the rest of the semester we're going to be talking about inheritance. And I'm going to start today's lecture off with a little bit of finger painting, whatever you want to call it. All right, so inheritance is a complicated thing because different languages handle inheritance differently. The Java way is not everybody's favorite necessarily. Java has some pretty unique ideas about how inheritance should work that a lot of other languages share, but not all of them. And inheritance is just a really hard problem to solve in general. So the problem boils down to if a thing is partially another thing, how do we classify it as an object? I know that seems very vague, but that's basically the problem. So let me give you the canonical example of how Java does its inheritance, basically. Everybody's taken some kind of biology class before, I hope, right? And you should know that in biology, every creature, every living creature has a single place on this big hierarchy of life, this phylogenetic tree, right? Let me look up a picture of the phylogenetic tree on Wikipedia. Here we go. Everybody knows that you get a single place on this giant tree and no more than a single place on this giant tree. So everything falls into a single kingdom, everything falls into a single class, and so forth, and then all the way down to species. So if you're going to talk about, let's say, let me bring back the white actually. I think that's easier to see. So if we're going to talk about, let's say, all of the animals in the world. So we would have animals at the top as the topmost category, right? What are the different kinds of animals that there are? Post in either chat. What different kinds of animals are there? I'll look up my goal at the end here. Let's say that my goal is to get to Homo sapien here at the bottom. Right? How am I going to get down to Homo sapien? So I'm going to end up in the mammals category at some point there. Right? But then there are other kinds of animals too. There's also like amphibians, yeah, in that same category as mammals, I think. By the way, it's probably terrible biology. I don't care about the biology at all, so don't use this on your biology exam or whatever. Maybe amphibians and mammals aren't even on the same tier in the tree. You know, kingdom, phylum, class. The one that starts with O. Yeah, you got your reptiles, and at the bottom of these somewhere are things like snakes, and the bottom of amphibians somewhere are things like frog. What do you have between reptile and a snake, an amphibian and frog, or a mammal and Homo sapien? Let me draw the lines while we're working here. This is going to be, everything goes back to animals, animalia. Right, so reptiles, amphibians, and mammals, those are all animals. They have a connection to their parents. But you can't be more than one thing. You can't be an animal and a bacteria. You can't be an animal and a plant. You can't be an animal and a fungus. So above animals, we have other categories, and you can only be one of those. Okay. I mean, before animals, we have things like chordates and non-chordates, so things with the spine and things like that. Those are easy categories, right? But what happens when you try to put, let's say, this guy comes along. Let's say this guy comes along out of nowhere. And he has a bill, like a bird, and he gives milk to his young like a mammal, but he lays eggs like a bird or a reptile. And he's kind of fuzzy like a mammal, but he lives in the water like a fish or an amphibian. That's the duck-billed platypus, of course. When you have a very rigid one-to-one hierarchy like this, it's like, where do I put this guy? Because you didn't expect the duck-billed platypus to come along, and as he did, you kind of have to figure out where to put him, and at the end of the day, you are pigeonholing him, because hierarchies like this, where everything can only have one parent, are rigid and difficult to work with. And Java is exactly a hierarchy like this, where every object can only have a single parent object. So as it turns out, the platypus is in the same class as us. It's a mammal. And then in the rest of the tree, in the order and the family, it basically has to live on its own because there's nothing quite like it, which is essentially you having to make special cases just for the platypus. So this is a hierarchy of one to many. You have one parent object with many children, but each child only has a single parent. And this is the kind of hierarchy that Java presents us. So each object can only extend a single other class. We'll see what that means later, but keep that in mind. So what other kinds of hierarchies are there? And name one that behaves in that way. So let's think of another hierarchy. What other kinds of hierarchies are there? And think of something in the real world that is organized that way. Yeah, there's vassals and lordship. You have one king at the top, and then you have maybe lord, lord, lord. You got your lord, lord, lord. You got your vassals beneath each lord. And then at the bottom you got your bunch of peasants. And again, you have a one-to-one hierarchy here. Every lord only serves a single king. Every vassal only serves a single lord. And then the peasants only serve a single vassal most of the time. But if you wanted to make some kind of separation, let's say that these peasants serve two vassals, that would break this hierarchy. That's not permissible. So this is another one-to-many hierarchy, just like Java's, where each child can only have one parent. And by the way, when we draw hierarchies, some people draw them left to right, some people draw them top to bottom. Generally, you don't see them bottom to top or right to left, so use this format if you're going to be sketching out yours. So you've got your one-to-one relationship here, and we can obviously think of situations where it is problematic because one person is supposed to be connected to, let's say, multiple lords, but they can't be because it's a one-to-many hierarchy. Every child can only have one parent. So again, a rigid hierarchy that occasionally has problems. How about a hierarchy that does not behave in this way? Can you think of any hierarchies that are not one-to-many? Think of any hierarchies that are not one-to-many. A hierarchy where children can have multiple parents. There's a pretty obvious one for children having multiple parents. Probably the most obvious hierarchy of them all. Yeah, you got your family hierarchy, right? The most obvious of them all. You've got you at some point, and your siblings, right? And then you guys have, well, you might have different parents, but you at least have at least one and only one father and only one mother. So this is a hierarchy that is the other way around, except that not only can parent nodes, or not only can children nodes have more than one parent, in fact they have two, but also your parent nodes can have more than one child. So this tree gets pretty big pretty fast, right? So this is Dad's dad up here, and Dad's mom, so your paternal grandparents, and then Mom's dad and Mom's mom, and then your maternal uncles and aunts over there. So you've got your father connected to their parents, your mother connected to their parents, and then them also connected to your maternal uncles and aunts. So this kind of tree gets very complicated very quickly, which you can see right away as the disadvantage of this kind of hierarchy versus a rigid one like this. These are easy to follow. These, not so much. This is a particularly weird hierarchy, the family one, right? Because every child node has exactly two parents. But, well, biologically at least. But the parents can have as many children as feasible. So this is a little bit of a different one. Can you think of any other hierarchies that are not one parent to, or one parent per child? Think of any other hierarchies where children can have more than one parent. And again, this one is not how Java works. And not how most hierarchies work, I guess, because this one has those two parents specifically. But what other hierarchies can we think of? There's school, yeah, there's different levels of authority or such. You can have school and work and all these different places where you have a not particularly strict hierarchy, teachers and students, or some kind of organizational structure. With teachers and students, you have multiple teachers responsible for the same student at different times, and likewise you could say in a company you have the CEO with maybe the COO on a direct report to them, maybe the CTO and the CFO on a direct report to them, or maybe you can consider them in their own category. It depends on your structure. And then all the way down here you have, Steve from accounting. And, well, who does Steve from accounting have to report to? He has to report to maybe manager A. He also probably has to report to manager B. Manager A and B have to report to bigger manager C. And those guys eventually report to the CTO. So you have a relationship where one child can have as many parents as they want. There's no limit to how many managers you could have, right? So you have a hierarchy where there's no limit to how many parents you can have. And this is desirable most of the time, even though it's confusing. This is generally the situation we want to be in for the maximum amount of flexibility. We want to be able to give our child nodes as many parents as necessary. But this is not what we get in Java. We get this one-to-one inheritance. So let's see what that looks like in practice. I'm going to add start up here. A new package, I'll call this inheritance intro. And I'm going to make this a visual program. I find that to be easier for these kinds of things. So I'm going to copy the swing starter. And while we're copying the swing starter, I'm going to look up display, and I'm going to show you where the inheritance is already that we've learned. So when I told you that we were going to gloss over this extends and implements until later, the extends and the implements are the two ways in which Java facilitates inheritance. Extends is traditional inheritance, and implements is multi-inheritance, which allows children to have multiple parents. Java supports both to some capacity. So if you extend an object, you can think of the word extend as a synonym for is a. Or even better, you should say something like is completely a. So if display extends JPanel, then display is completely a JPanel. Displays can do everything that JPanels can do, and that includes drawing things to the screen and resizing and everything else, because they inherit directly all of the different properties of JPanel. And this is what allows us to do things like set preferred size, set preferred background. Even though we don't have those methods written anywhere here, we inherit all of them from JPanel, and that's where all of these come from. So the paint component method, all of these different things that we use without having the methods in our program anywhere, those are all inherited from the JPanel. And that's basically the reason that we do inheritance. That's the power of inheritance. We write an object once, and then we utilize its properties throughout the program later by extending that object, or later on we'll look at implementing it in different places. Okay, so I'm going to make a new class for my top level object that all of the others are going to extend. I'm going to call it CCreature. And I don't want you to get too much into the habit of thinking that inheritance is just for constructing real-world hierarchies. But for this early example, I wanted to use an animal-based one, since animals are very well organized into these kinds of hierarchies. Later on, we'll see some applications where just purely from a programming perspective, with no kind of real-world indication that it should be such, inheritance ends up being the better answer. Now, normally what you want to be thinking of when you want to decide whether an object should inherit from another is how much code they share in common. So let me go back for a second and look at some of our old examples. We have, for example, this pet class from back in the day where we described all of our different pets using an enum and then decided what they were going to do. We could have handled this using inheritance instead. We could have had a pet class, and we could have had all of those different pets be children. Maybe we'll do that later on. Here's another example. We had our sandwich shop example, and here we made sandwiches with different kinds of toppings. Again, we had to revert to enums in order to enumerate all our different toppings. And again, we could have created a class called topping and had all of our different toppings extend to that class so that all of them were children, and they would all share the same properties. And we'll see a lot of other examples as we go. Okay, so one of the first keywords that's associated with inheritance that we're going to look at today is abstract. And we're not going to look at this too much, but there's the keyword abstract. I've added it to the class here. And what abstract does is very much like what private does. It doesn't do anything really programmatically. It just gives you a foot gun so that you can tell other programmers, don't make this object. Let's see what that means in principle. Let me go back to the display and try to make a CCreature. So obviously the class is blank, but we should be able to make one. So CCreature creature equals new CCreature. And when I attempt to do this, it will give me an error, and it will tell me you cannot instantiate the type CCreature. And that is all that abstract does. Abstract tells other programmers you can't make this class. And the reason why you might want to do that is because you might want to communicate to others that you don't want to be able to make a CCreature. You need to make something that extends CCreature. You need to make something that is a CCreature. And that's the same way that our animal hierarchy works. So can you make, let's say, a mammal? Can you make a generic mammal? No, of course you can't. You can't make an amphibian. You can't make a reptile. It wouldn't make sense to make those things. You can make a snake, you can make a frog, you can make a platypus, or you can make a person, but you can't make a reptile, an amphibian, or a mammal. Those are abstractions that are part of an object that is much further down that you actually can make in practice. Okay, so you can't make a reptile, an amphibian, a mammal, but you can make a snake, a frog, a person. That means that reptiles, amphibians, mammals, those things are all abstract. Now going back to this hierarchy, in this hierarchy, none of the classes are abstract, but they also don't inherit from each other at all. So this isn't an inheritance hierarchy. This one is only structural. What do kings do that lords do? Not really much. They don't really, in terms of the whole feudalism concept, I mean, obviously they're all people, so they share a lot of things in common. But in terms of this hierarchy, just describing feudalism, they don't really have anything in common. So a lord doesn't extend a king, because a lord isn't a kind of king. It's not completely a king. A lord isn't a king, a vassal isn't a lord, and a peasant isn't a vassal. So this isn't really an inheritance hierarchy. It's a different kind of hierarchy. That's another catch that you have to think of. Not every hierarchy is an inheritance hierarchy. Now, in the sense that at least all of your ancestors had to have at least one kid, if you rule out you, then every dad is a kind of dad's dad eventually, and every mom is a kind of mom's mom eventually, because, obviously for your lineage to have propagated, that has to be true at every point in your ancestral lineage, right? So in this case, we do have some inheritance, but you only end up inheriting from one of the parents. So this is a kind of hierarchy that's very difficult to represent programmatically. You only end up inheriting properties essentially from one of your parents, at least in the lineage sense. Again, there are different ways to think about people's properties, but that's a digression. And here, again, you don't inherit anything. The CTO is not a CEO. The manager is not a kind of CTO. Manager A is not a kind of manager C. So this, too, is not an inheritance hierarchy. All right, but going back to sea creature, which is abstract because you can't make a sea creature. I'm going to give it a constructor. What do all sea creatures have in common? Let's think about what do all sea creatures have in common. You can give me any stupid answer that you want to give me. I don't care. And then we'll have a draw method because we want all sea creatures to be drawable somehow. So what do all sea creatures have in common? I'll commit this to the sync repository so you can get started. If you want to sync on your end. What did I do? Oh. Error, right. Okay. So all sea creatures should be able to swim. We'll make this a void for now and then figure it out later. What it's going to do. We're not sure. I can think of some other things that sea creatures can do. I'm also going to take a poll. Let's see how many people figured out the Git integration with Eclipse. Figured out the Git integration. At least you got it working according to that tutorial, and hopefully you can get the content from a GitHub repository back to your machine. So if you still haven't done it, I suggest you try again. You go back. And if you have any problems again, post in Discord. I'll help you. Someone else who's gotten it working will help you. It'll make it a lot easier for you to follow along and for you to sync up what we're doing in class. So you can just load this all the packages and everything into your Eclipse with 2 clicks. That's going to be very convenient for you, especially for exams and such. You don't have to worry about searching for, where did I do this program, where did I do this? Just load up everything we did in class exactly as it appears. So give it another shot if you haven't already. I might repost that tutorial again if it's too far scrolled behind, but if not, just locate it there and we'll go with it. Alright, well, that's fine for now. We're going to think of the common properties of sea creatures, I guess, a little bit later. And this is usually how it's going to work. It's usually not something that you plan completely up front, the construction of these object hierarchies. It's usually something that happens organically as you realize that two different objects that you're planning to make are very, very similar, and they could end up being organized into a hierarchy. Alright, so give me an example of a couple sea creatures. I'm going to make a couple classes for the different sea creatures. Give me a couple sea creatures. And don't give me any lake or river creatures. I want to see sea. That means salt water. Ocean. Crab. Crab. That's a good one because crab already indicates that our hierarchy has a problem. What is the problem that crab presents? Crab, whale, and shark. What is the problem that crab presents? What is crab's problem? Crabs can't swim. Yeah. Crabs can't swim. So crabs violate the hierarchy already because crabs can't swim. Alright, let's still set this up and see what we can do about that when you run into a situation where you've realized that the hierarchy you've set up is actually flawed. So in order for crab to be a kind of sea creature, we want to use this word extends in the class declaration. So crab extends sea creature. And we're going to add that to our other two classes as well. We're going to add that to whale, and we're going to add that to shark. So crab extends sea creature, whale extends sea creature, and shark extends sea creature. Lovely. Okay. Now we want them all to be drawable to the screen, but for now, we don't have any kind of thing to draw. The draw method is just blank. It's just blank. And also the constructor is blank. So I think I'm going to declare a couple of things that all sea creatures should have in common. So I'm going to give them an X, I'm going to give them a Y, and we're going to omit the size. I'm going to specify those on a per creature basis. So I think those are things that all sea creatures should have in common. And I'll add them as fields here. This.x equals x, and this.y equals y. So I've just added a couple of fields. And after I save, you'll notice that the other three classes, the ones that extend sea creature, have all triggered an error, right? And if you think about why this is, it becomes pretty obvious. When you create an object in Java, you need to do everything that the constructor asks for. We know that. If you don't give the constructor all the arguments that it's looking for, you're going to get an error. And well, if a crab is a kind of sea creature, then when you make a crab, you are also, by extension, making a sea creature. You're actually making both kinds of things at the same time. It just happens to be that a crab is a sea creature, but that still means that you have to fulfill all of the guarantees that sea creature's constructor requires. So if sea creature's constructor requires an x and a y, then somehow crab has to present those to sea creature. So if sea creature's constructor requires something, then somehow crab has to present those requirements. If I let Eclipse automatically fix this for me, we'll find a constructor with an interesting format. We find that our constructor is named crab, as it should be. It takes an x and a y, as we'd expect. And then we see this weird keyword, super, this keyword that we've actually seen one time before back here in display. We saw the keyword super used. Super is another one of those keywords that sounds really complicated, like this, right? We know that this is pretty complicated. But much like this, super has a very simple meaning. It means the class that this class extends. So super, maybe this will be a long comment. Super means the class that this class extends. In this case, that's C creature. So super something calls the constructor in C creature. Well, in the object you extend. Here, that's C creature's constructor. And to prove this to you, I'm going to write a comment on C creature. And let's write creates a new C creature at the given position. Okay. And if we hover over super, we see that it's actually just giving us the documentation for that constructor that I just made for C creature. So all I'm doing here is calling the constructor. It's very similar, but not quite the same as something like well, it would be something like this. It's kind of a shorthand for something like that, but not quite, because this isn't really a sea creature. It's a crab, which is a kind of sea creature. But you can think of it as something like that. We're actually creating a new sea creature at the same time we create a crab. This object just happens to have properties of both. You don't always have to take the same arguments on the children as you do on the parents, so it's possible that we take more than the x and the y, for example. Let's say that I also wanted to have a color for my crab. Let's say I also wanted to take a color for my crab. Creates a new crab with the given x, y, and a color. Okay. Now how do I want to build my crab structurally? Let's say I think my crab should be made out of rectangles because that's what I've got the bandwidth for today. Still recovering from daylight savings, so I'm going to go with rectangles. Rectangle 2D dot double, we're going to call this the base of the crab. And then we're going to make two rectangles for his pinchers. Left pincher and right pincher. Left pincher and right pincher. Okay, and I'm going to instantiate those. Let's give it a size too. Let's say that all of those things are going to be squares for simplicity. So public static final double. Let's call this base size is going to be 50. And pincher size is going to be, I don't know, 15 or something. Doesn't really matter. Alright, and back to my drawing board in Paint. Let me show you what my beautiful vision is for this crab. So I want to see this as his base, and then I want to see two pinchers like that, and then let's go with, I don't know, we can call it a day there, or maybe we can make some antennae for him. It seems pretty good. You know, ideally we do some antennae and some legs. That'd be really top crab, but we'll just go with the pinchers for now and then go from there. Maybe we can do the legs too. Alright, so the base, the top left corner of the base is right there, and the top left corner obviously of the two pinchers are there and there. So start thinking about how we're going to locate these, because it's not simple, right? If the top left corner that we're dealing with is right there, how are we going to locate these darn pinchers? Okay, let's go. Let's do it. I'm going to make a method for this. We'll call it place grab. And this is going to take an x and a y as an argument. And it's going to place the crab's visual components. I want to regenerate this because I made parameters. So places the crab's visual components where they belong. Okay, so let's think. If the base belongs at that x and y location, where is the first pincher? So where is the first pincher? Where does the left pincher go? Where does the left pincher go? This guy. Where does the left pincher go? Stuff's gonna become second nature to you eventually, because we're gonna end up doing a lot of it. Not that I'm gonna ask you a lot of exam or homework style questions where you have to position these kinds of things, but this kind of front-end work, manually positioning things based in their position, it's good to get a feel for that, because you end up doing it a lot no matter how much you try to avoid it. So we're looking at the x minus the pincher size, as we saw in the Discord there, and y minus the pincher size. Is that right? Is up negative? Yes, it is. Convenient sometimes. We could use the bases x and the y, but here those are the same because we just designated those as the bases x and y anyway, so that ought to be fine. And then the size is obviously pincher size instead of base size. All right, what do I need to do with the right pincher? Where do I place the right pincher? Guy over there. So again, the base is top left corner that we're referring to right there, whereas the top left corner we want to place the pincher at properly way over there. You should note that we've got the width of the base to think about, at least, right? That gets us over to here, the width of the base. And then height-wise, I think we've already solved that problem. Right, so the only difference now is that instead of x minus pincher size, which brings us here, we're doing x plus the basis size, which brings us over to there on the x-axis. So we're going to do x plus the base size. Okay, and that should place all of our crab's components in the right positions. Now, here's a question. Let's say that instead of being public, these x and these y values, well, default right now because I didn't say. Let's say that they were private. Let's say that they were private. Would I still be able to use them here in crab? I need to think about that. Let's think about, do private values in the parent class, are those still usable in the children? So is crab able to use private values from C creature, and why or why not? So think about that for a bit. All right, I'm going to place crab here. All right. You've thought about it for a minute or for a few seconds, so let me get your answer. I'm going to take a poll. I'll say, can crab C use sea creatures private fields? Can crab use sea creatures private fields? Well, we're only talking about Java here, and it's going to be similar in most languages that are object-oriented languages. So yeah, when I ask any of these questions, I'm just referring to Java. But we have most people guessing yes, and guessing yes because it's a child. And the answer is that's true, right? You can use the x and the y. In fact, I can type them out here. This dot x. Where is it? Let me try again. Let me put it inside another method so you don't have that interference with the x and the y from crab. So this is let's say another method here. Let's say I wanted to access that x. If I type this dot x, I get nothing. Right? Try it again. This dot x, nothing there. But if I just type x, then what? SeaCreature.x is not visible. And what's the recommendation that it gives me? It tells me that I could change them to protected. Let me do that real quick. Now I've changed them to protected. And that brings us to what protected means and why the default in Java is public-ish. Because by default in Java, yes, you can use all of the fields of the parent class. And it would be a good guess to assume that you can use all of the fields that are private of the parent class. But it turns out that occasionally you want to restrict access to certain fields in the parent class. And private lets you do that, whereas protected lets you restrict access from other classes that don't inherit it, but gives access to the children. So protected is like private, but also allowing access to the children classes. That's the hallmark of protected. So if I wanted sea crab and whale and shark to be able to access this x and this y, I would have to give them access like that via the protected. Or I could give them a getter too. And you can kind of see that in display, right? So we have this this.getWidth option, right? So we are able to access the width that way, but remember we don't have a field to access the width directly. We can't just say this.width. So they made the width on the panel private so that you couldn't accidentally ruin it, because if you tried to set it manually, it wouldn't do all of the other things that it has to do when you change the width, like resizing the screen and resizing the frame. So they gave you this getWidth method without giving you access to the field, and that's going to be the more common approach, I would say. So today we're going to make all of them protected or public, kind of the same thing here, but we'll see the difference in a bit as well. All right, so a little counterintuitive there. No, you can't if they're private, but yes, you can if they're protected. All right, so we've placed the crab and all that good stuff. Now it's time to draw it. We note that the draw method on SeaCreature is currently blank. Can we do this? Can we draw our crab's three shapes? Can we draw the base, the left pincher, the right pincher? Can we do that here? Can we do it in SeaCreature? No, we can't, because not every SeaCreature is going to draw in the same way. So I'm going to print here. Draw method does nothing. Okay. And what do we do if we want our SeaCreature to draw successfully? Well, we've already done this before with the toString method, and actually with displays paint component method as well. We're going to do something called an override in order to write our own version of the draw method for each of the children. So we're going to write a method that has the same name and takes the same arguments. That graphics 2DG. And when we do that and we solve all our errors and everything, we're going to see this little green arrow pop up on the left-hand side, just like we saw for toString, and just like if you look at display, you can see in paint component as well. And that indicates that we have overridden our built-in method from the parent. So if a child implements a method slightly differently, so let's say that you have 3 children, as we have here, a crab, a whale, and a shark, and they all are capable of drawing themselves to the screen, but all 3 of them draw themselves to the screen a little bit differently. Likewise for your display panels, right? There are all kinds of different display panels you might want to make in the world, but all of them draw themselves to the screen a little bit differently. So you give yourself this paint component method that allows them all to designate how that they are going to draw. You might ask, well, what's the advantage of having it on SeaCreature at all then? Why don't we just get rid of draw here? Why do we need a blank or do nothing kind of draw method here? Well, we'll see. First I'm going to write a comment for this. All SeaCreatures should draw themselves to the screen. This default method does nothing. Okay, so that's the document for that one. Whereas here I'm going to say draws this crab to the screen. And then I'll do the usual. I'll set the color to whatever I'm going to set it to. So I have a color designated above. I also forgot to link the color together here and to actually make a color field. So let me do that real quick. I got private color. And I want to do just that color equals color. So we've done all that before. And then I'll set the color to color and draw the crab. So I want to fill the base, and I want to fill both pinchers. And then I'll set the color to black and do the outline. Okay, maybe if we have some time at the end, I'll also make some funny crab legs. Maybe not. Okay. So that's crab. Let me fix the errors in whale and shark real quick, and then I'm going to go and make a crab in my panel. So I'm going to leave the to-do step. The purpose of these to-do steps is to show you that that was automatically generated by Eclipse, and it needs a human to look at it. So once you, the human, have looked at it, you should delete the stub that tells you that it was auto-generated, and you should look at it. Okay, so let's go back to the display and create a crab. Easiest way for us to create a crab is going to be the way that we're used to. So let's say crabby equals new crab. What did we need? An X and a Y position? Let's call it 100, so he's more towards the middle of the screen. Forgot the word new there. Oh, needs a color too. Let's call this a blue crab. It's going to be a beautiful blue crab, and I'm going to draw him to the screen using his draw method. Which comment am I going to see here? Am I going to see the comment that I wrote on crab, or am I going to see the comment that I wrote on SeaCreature? If I hover over this draw, which draw method is it going to be utilizing? The one that I see on crab or the one that I see on SeaCreature? It's going to be the one from crab. But it tells me that it overrides the draw from SeaCreature. So it actually tells me as well, and it gives me an automatic link. I can just click it and go right to the documentation for the original, which is very helpful as well. All right, so let's run this. There's my crab, beautiful little blue crab. And let's look at another way that you can actually declare a crab that is a valid statement. So instead of the crab being of type crab, the cool thing that you can do when you have children is declare them as their parents. So we can do this. We can say sea creature crabby is a new crab. Sea creature crabby is a new crab. Since a crab is a kind of sea creature, this is a valid expression, and it will draw the crab to the screen still, so everything's all good there. And now if you hover over this draw method, you do get the documentation for sea creature. But our guy is being drawn successfully, so what gives? Which draw method is actually executing? Is it this one, or is it the one that it inherits, the original? So when I run this program, which draw method is actually getting executed? Is it the draw method that I wrote in crab, or the one that I wrote in sea creature? The one that I wrote in crab, or the one that I wrote in sea creature? I made a poll. So most people are saying crab, and that's the right answer, even though it's giving me the documentation for the sea creature variant. At runtime, Java is smart enough to figure out that this is a crab, actually, and it needs to execute that one. So we'll execute the child's implementations of those methods, which is really convenient. Now, what was to happen if we didn't have this draw method at all? If I commented out, well, then we would have an error because crab no longer has a draw method, or sea creature no longer has a draw method for us to reference. So not having it there, well, that is a problem. So you might also want to designate, when you have methods like this where the default does nothing, you can also designate that the methods are abstract, but this leads to some other requirements. Abstract methods can't have anything inside of them, so I tend to avoid doing this. Okay, so an abstract method is just exactly what we were using this as, a guarantee that the sea creature will have this method, but no actual implementation. This forces whale and shark to have an error because they don't implement a draw method. So when you have an abstract method like this, you're making a promise. This class will have our draw method. Okay. If it doesn't have the draw method, then it's an error. That's what you're saying. What happens when you get rid of paint component in the display? Nothing, because it's not abstract. You can have a display with no paint component. You don't need to make that guarantee. And so if it's possible for you to have a sea creature that doesn't draw itself, which may very well be the case, then you shouldn't make it abstract because you don't want to make that promise. And that's the problem with abstract and why I generally don't use it when I'm creating a template for a parent object like this. It forces you to fulfill that promise in all of the child objects. Now you could give them that method and it could be blank, so there's different workarounds, but still, if you don't want to guarantee that, if you don't want to make that promise that all the children must have their own version of this method, then don't make methods abstract. The other thing that you'll note is that you weren't allowed to have a method body. It got rid of these curly brackets, and it got rid of the inside, and it had just a semicolon on the end, right? But what if I want to print an error like this when you use the default method? What if I do want something to happen when you use the default version? Well, then I can't make it abstract either. So those are a couple downsides to abstract. We won't see a lot of abstract methods or abstract variables for those reasons, because I don't like to guarantee those promises usually. But let's just do one for the sake of having one in this program so that you have an example to look at. Let's make our swim method abstract. Okay, so it's going to remove the method body. There is no default variant of swim, and if I save this, then there's an error in all three of these. I need to add the swim method to all of them. I can use Eclipse to automatically add them for me, which I'm going to do. Okay. All right. So, got about 15 minutes left. Let's make one of the other objects before we do swim, and we'll get to swim next time. So let's make a whale. What should a whale look like? Anybody want to draw me a picture of a whale while I work on... I'm going to work on adding the constructor details and such. Let me know what beautiful geometrically oriented whale you would like to see. Let's say whale takes something different. Whale takes a size. We'll call it fatness. So whale and crab now have different constructors. Crab takes a color, whale takes a size. Okay, we'll have a couple of fields here. We'll do fatness to length ratio. It's going to be 2. And all whales will have a color. I didn't need to do this since I've already designated a, whoops, since I've already designated, white's already been designated before in the color class. I didn't have to do this, but just for consistency with crab, I'm going to keep the color there. Okay, no one wanted to draw me a cool geometric crab. So let's use an ellipse, or whale. Let's use an ellipse as the base of our whale. Try to make a whale look terrible. Share it. Let's go. We're going to use your whale. It doesn't matter how awful it is. That's the goal here in swing art. Show us, show us, show us. Whoever posts the first whale-like creature, I'm going to make it. Just go on Wikipedia and find a hyper-detailed picture of a whale. We'll be here all day. The heck is that? Is that a crab or a whale? Woo! Oh, is that the tail? Is that supposed to be the tail of the whale? Alright. I think I get it. Alright. Yeah. Okay. So we'll go with a round body then, but we'll go with a rectangle for a tail. Or we can go with bodies. I probably pull that off. A little polygon drawing tool. And your whale's missing an eyeball. I'm going to do an eyeball. Just call it eye. Okay, and I'll do the same thing that I did for crab, where I'm going to go with place. So I'll call it place whale. Place whale instead. Alright, so the base is an ellipse instead of a rectangle. I'm going to put it at the same place. We're going to store the fatness as a field. So this dot fatness equals fatness in the constructor. And then I'm going to use the fatness will be the height of the whale, and the length of the whale is proportional to the fatness to length ratio of the whale. So you want something twice as long as it is tall? There you go. You've got twice as long. You want to make it 3 times as long? There you go. All right. We've got the tail and then the eye. Okay, so I want to position the tail at the back of this thing. I'm going to put mine on the right-hand side. So if I want it at the back, then I have to add this width of the whale there. So it's going to be x plus the fatness times the fatness to length ratio. And then I want it to be halfway down. So that's going to be about fatness over 2. That actually doesn't quite bring you exactly halfway, because you also have to subtract half the tail size. But hey, I got better stuff to do today than to position this tail. How big do I want it to be? Let's say I want it to be 1/3 of the size of the whale. 1/3. I'll go fatness over 3 for the tail's position. Where do I want the eyeball? Well, I'm going to cheat a little bit and do a couple magic numbers here, I think, just to make it simple. So we'll go with x plus 20 and y plus 20 to put it somewhere in size of the whale, and we'll go with 10 for the size of the eyeball. And that's an ellipse, not a rectangle. Okay. And I need more than just color. I probably need an eye color too, so let me rename these. I'll call this base color, and then we'll go with an eye color. Whales have beautiful blue eyes, probably. I don't know. I've never seen a whale that close. Pretty sure they just have black eyes, but we'll go with blue. Alright. Now I have to generate the draw method for this. Again, I'm going to take a copy out of crab and then modify it. After I finish this method, I will sync it, and once you've got GitHub set up, you can ask me anytime in class. Just put sync in either chat, and I will sync it over to there, and you can get it into your Eclipse right away. So if you ever made a mistake or you fell behind in typing but you want to follow along, as long as you have GitHub integration set up, just let me know. I'll sync it, you'll download it, and you'll be right where I am. Okay, so the base color, I want to fill the base and the tail in that color, and then I want to set it to the eye color, and then I want to fill the eye, and then I want to give everything an outline in black, and that should do it for the whale. Of course, got to change the comment to draws this whale to the screen. Draws this whale to the screen. Alright, so that's my whale. I'm still going to leave swim blank. I don't think I wrote anything else on crab either. I think I just had that place crab, that's it, yep. I've got the same super, note that I've got the same super as I had in crab. Place the whale there. They both take that x and y argument and they pass it along to sea creature's constructor. Now let me go back to the display and make another sea creature. So this will be sea creature whaley. Whaley will be over further down on the screen. And note that whaley takes different arguments in his constructor. Whaley takes a fatness dimension instead of a color. Let's see what whaley ends up looking like. Wow, beautiful. Whaley's tail got a little bit cut off there. I want to get him on the screen. Let's move him over a bit. There we go. Not quite, huh? First of all, his tail's floating up in oblivion, and, well, his eyeball is off his body, so I should probably work on that a bit. Let's go back and fix it. So 20 obviously isn't enough. It looks like I am going to have to use something proportional to the body after all. So let's go with fatness over 4 maybe. Maybe over 8. We'll try that out. In terms of positioning the tail, what did I do wrong? Well, it looks like I did y minus fatness over 2. Is that the right answer for placing it along the y-axis? Because look at where it ends up. It ends up way too high, right? What should I have done if I wanted to place it in the right place? Eyeball's still off. Well, at least the eyeball's inside now. So it's a start, Whaley. Although that's a real small eye for such a large and majestic creature. So yeah, I would prefer to add it. That gets me kind of halfway down there. Oh gosh, don't buy a Razer keyboard. Piece of garbage. Alright. That isn't really great, is it? It's not the most tremendous tail out there. So like I said, if I want it perfectly centered, I'm also going to have to subtract half of the tail's size. And the tail is fatness over 3 big, so I actually have to subtract fatness over 6 if I want to do the math, or I could do variables for all those things, but I'd rather do the math. And there we go. I got a whale with a tail, sort of, if you're really generous. Okay, so that's my whale. Now I have 2 objects that both inherit from sea creature and implement the draw method differently. What if I did this? What if I did sea creature, creatures of the sea? Let's just go with creatures. I can't retype that every time. Sea creature, creatures equals new. Sea creature. Let's make it 10 big. What if I did this? What would I have to do in order to add crabs and whales to my sea creature array? Oh, I forgot to sync as well, so let me do that. Added whale and crab with the mix. Did I break anything? No, just do it. Okay, cool. Well, I have an array of sea creatures. So first question, can crabs and whales occupy the same array? I'll do a poll. Can crabs and whales occupy the same array? I'm going to populate the array in the constructor as we usually do while you think about it. Can crabs and whales occupy the same array? Yes, yes they can. Like everyone says in the poll, they can because they are both sea creatures. So just like we can create them individually as sea creatures, so too can we create a whole array of them. How do I decide? Let's say I want to randomly flip a coin, 50-50, and make either a crab or a whale. How do I do that? So for every spot that's available in the array, I want to flip a coin and either make a crab or a whale with a 50-50 chance. Crab or whale with 50-50 chance. So it's going to be one of these. It's going to be creatures of I is equal to whale, or it's going to be creatures of I is equal to crab. but what else needs to go there in order to facilitate that? 50-50 shot. This is also a question in what's the fastest way in Java to get a coin toss? Most people probably are thinking something along the lines of roll a number between 0 and 100, or roll a Boolean or something, figure out how to do that. What's the quickest math.random statement to get a 50-50 shot? And I'm going to put these guys in random positions on the screen. So I'm going to do math.random times width and times the height of the panel, obviously. Get these placed in random places. And that means some of them are going to be slightly off the screen, but that's fine. I've done that for all the examples. So if math.random we said, and then something has to happen. Quickest way to get a coin toss. It's going to be something. Yeah, greater than 0.5 is the fastest way to get 50-50, right? Math.random gives you a number between 0 and 1, so split 0.5. I like to do greater than 0.5. You can do greater than equal to. It doesn't matter. You can do less than 0.5. It doesn't matter. Remember that 1 is excluded from the range. The largest math.random can be is 0.99999, whatever. It'll never be 1. So technically, there's just ever so slightly more stuff less than 0.5 as there is bigger than 0.5. But I really wouldn't worry about that since that's like 1 in a billion. Okay, so that makes either a crab or a whale with a 50-50 shot, and then let's draw them all to the screen. So creatures of I dot draw, and then G again. And if we hover over this again, we see the default methods documentation, not crab or whales documentation. Run it, and we get the most beautiful visage of the ocean. Just little crabs and whales living in harmony at the bottom of the sea. You know, I really should have started with this in the first place, but I gotta go back to the driver and make the water a nicer color. Look at that sparkling blue water right there. Isn't that lovely? Wow. It's really, really majestic. I don't know why they seem to always be clustered on the bottom. I don't know if that's just bad luck or if I made a mistake here. So it looks like they can't occupy the top left corner for some reason. Is it really that bad luck? Oh, there's one in the top left. Okay. It's bad luck, I guess. Yeah, it feels just like you're in an aquarium. So next time we'll continue with this. We'll look at how inheritance benefits us further. But today I think you've seen the biggest benefit to inheritance is that you can create a parent object that has a bunch of children, and then you can instantiate an array or whatever you wish of the parent object, and then you treat all of the children the same. This is what I want you to really try to hammer home and memorize, is that when you have an array of objects, regardless of what the children do, regardless of their implementation, everything, for it to be good object-oriented programming, you need to be able to treat all of those objects the same. So if you ever have a situation where you need to check, is this a crab or is this a whale in order to do what you need to do, then you've made a mistake. You need to treat all of these as sea creatures, and then they handle their behavior on the object in whatever way they wish. So I'm going to keep emphasizing that, but I want to just point it out for the first time. All right, see you next time. Enjoy your beautiful aquarium. I will sync this up one last time to GitHub and then upload it to Canvas. Adios.